One of the hardest parts about understanding hypothesis testing is actually setting up the problem, being able to understand the core logic of such a test. We said in the court system that the null hypothesis, the default when you show up, is that you are innocent. But that's not the goal of the court system. The goal of the court system is to find people who are guilty and give them a fair way to be tried. So we are trying to prove the alternative by saying that the null is unlikely. In court, they argue that it's very unlikely that someone is innocent because of all of this evidence against them, therefore they must be guilty. Let's look at that in some other context. Imagine you work at a restaurant and you sell appetizers as you are greeting customers as they sit down. And now you're wondering, does mentioning a specific appetizer increase the total sales of appetizers? So you sit down and someone says to you, would you like an appetizer? You might say yes or no. Instead, they might say, do you want to try our blooming onion, our favorite appetizer? And you want to see if mentioning that specific name instead of just the general term is going to increase your sales. Now the goal is the alternative, so sometimes you even want to start with the alternative. More people are going to buy appetizers is maybe what you are thinking. You're assuming that this is going to help. So that's your alternative, that's what you're trying to prove. Working backwards to the null would be saying that no, the sales are not going to change. So again, the null is always a measure of no difference. Nothing is going to change. Sales will not change. Doing something different won't affect anything. The alternative is what you're seeking, what you're hoping to find. More people are going to buy appetizers in this case. Another example. Readers found an average of 45 errors in an essay by Jack McConnell. Would they find more errors in the exact same essay by Xiaoping Zhang? The idea here is that they took the exact same paper, copy and pasted it with a different name at the top, and had students read it. And this was actually part of an actual study to see if someone's name sounding foreign affected their bias as they were reading, if they would detect more errors just because of that name bias at the top. So let's start with the parameter that we're actually talking about. We're measuring errors. So average number of errors in the essay. And you want to compare Jack to Xiaoping. So the parameter is the number of errors, and you're looking at the average, so you're talking about mu. The null hypothesis, we always say, is no change. So let's jump to our alternative. We're assuming that somehow having a more foreign sounding name is going to lead people to find more errors. So the number of errors goes up. And thus, the null would be that the number of errors does not change. Our alternative, using the symbols here, since we're dealing with an average, we have mu. And we think mu is going to be greater than the 45 errors that was in the original essay by Jack. The null then, of course, is that it does not change. So mu equals 45. The standard of evidence, we kind of mentioned that earlier, is how unlikely the null has to be before we are convinced that the alternative must be true. And in most cases, we're always going to say 5%, an alpha value of 0.05. The only time that we would do something different is if we potentially have a life or death situation, or we're afraid of a lawsuit, or there's some reason why we're afraid of making an error. So we would up our level of evidence that we would require. Next thought, that guy right here, his average fairway shot with a 3-wood goes 214 yards. Would he hit it a different distance with a 3-iron? So we're looking at the same person, same type of shots. They want to know if one golf club works better than another, which one is going to hit farther than the other. Our parameter is always what we're actually measuring. So the average fairway shot, we're talking about an average of some sort, so we're talking about mu. And the 3 wood, we already know the average for that, so we're trying to measure the distance with the 3 iron. So average fairway shot with a 3 iron. And we're going to call that mu because it's an average of a bunch of numbers that we're going to collect. Each shot is a numerical value. Null hypothesis is always going to be some kind of measure of no difference. So let's start with our alternative. And we are assuming that not that it's going to go farther, not that it's going to go shorter, we just don't know. We want to know if it will be different. And this is something we haven't looked at yet. If something will be different. And so our alternative says that mu will not equal 214 yards. It will be different than that. So the average could be higher, it could be lower, we don't know. The average distance changes with a 3 iron. Going back to our null, we would say that the average distance then stays the same, and of course mu equals 214. The symbol with the null is always going to be an equal sign. Our alpha, our threshold value, always going to be 0.05 unless we have a reason to go higher or lower. And then last example. Currently, when asked what size would you like, 37% of customers order a large coffee. Does rephrasing this question as do you want a large make more people buy a large coffee? And when we talk about biased questions, we're wondering if this kind of changing the question you ask your customers can persuade them to get a large coffee more often. The assumption is, the thing that you're probably trying to prove if you came up with this idea, is that it would work. It would in fact make people buy a large coffee more than the default 37% of the time. So let's start out with our parameter and figure out what it is that we're actually trying to find. The number of large coffees that are purchased out of all of the population that comes to your store is what you're trying to guess. 37% of customers is the current value. So you're dealing with a proportion, whether they get a large or not. So the proportion of large coffees sold is going to be your parameter. Jump to our alternative. We're assuming that we're going to sell more. So we're going to say that the proportion of large coffees goes up, or P is greater than that original value of 37%. The null, of course, is that measure of no difference. The proportion of large coffees doesn't change, and P is going to equal 37%. Standard threshold here of alpha is going to be 0.05 again. Let's do a quick review of all the different types of hypotheses that we can get. Now when we're dealing with the mean, anytime we have quantitative data, our null hypothesis is always going to be mu is equal to some number. Now I have the number 7 here, but that could be mu equals 0, mu equals 14, whatever it might be. So mu equals is your null hypothesis. And then your alternative is that it's going to go up, it's going to go down, or it's going to be different. So for example, mu is greater than 7, or mu is less than 7, or mu is not equal to 7 would all be valid options here. And of course this number doesn't need to be 7, but what you do need to know is that the number on the null and the number on the alternative are going to be the same. So the only thing you do that's different between the null hypothesis and the alternative is just change the symbol from an equal sign to one of these three, greater than, less than, or not equal. Proportions are very similar. When you're dealing with categorical data, you're going to have P equal to some proportion of the population. So if it's 40%, P equals 0.4. If it's 30%, P equals 0.3, whatever it is. And so that number, of course, just like above, can change. And then you have the same idea with the greater than, less than, or not equal. If you think it's going to go up, P is greater than that number. If you think it's going to go down, it's less than. And if you're not sure if it's going to go up or down, you would just say not equal. And again, these numbers could be any number, but it's going to be the same in your null and in your alternative.